Hello everyone. So last class we discussed about the Newton's second law. Now today we're going to wind up the chapter with the last topic, that is Newton's third law. So as you know, Newton's third law is action-reaction law. It is also stated as action-reaction law. Now what does action-reaction law states here? It states that for every action there is always equal and opposite reaction. Means whenever there is certain action taking place in the nature, there is always equal amount reactions taking place. But the thing is, these action and reaction are occurring on two different bodies. So here I have taken certain example just to explain you. So let's begin one by one. This is your first example. In this example, what we have done is, we have taken a balloon, filled air in it, and then allow the air to come out of the balloon. So what will happen now? The air will rush in the downward direction. At the same time, the balloon will go upward. So this air going down is our action, balloon rising up is our reaction. Is another example where we have taken a ball of certain mass, which is dropped from some height. Let's say we have dropped it from h height. Now as the ball falls down onto the ground, the moment it hits the ground, that will be the action, and then it will bounce back as the reaction force. So this hitting the ground is your action and bouncing back is our reaction. This is the second example. Now see the third one. Here we have a person who is stepping away from a boat. This is our boat. This person is stepping away from the boat on the ground. This is your ground. So the moment he steps onto the ground, the boat goes backward. Why so? Because this person applied the force, backward force on the boat as an action. The boat pushes the man forward, that is reaction, and he reaches onto the ground. Repeat again. This boat, the person as he steps away, he applied a backward force on the boat as an action force, and boat as a reaction applied a forward force. This forward force makes the man to step away from the boat onto the ground. Now here I have a gun on which we have fired a bullet. Now when the bullet is fired, this forward force is being exerted on the bullet by the gun's barrel. So this forward force is our action. The moment a bullet is fired, the person who has fired feels a backward push. So that backward push or recoiling is our reaction. So this firing of bullet is the action, recoiling of the gun is our reaction. Fine, there are certain more examples as well. Even practical applications are there. So first of all, let's discuss about walking. Have you ever wondered that how we are able to walk on the ground? If not, let's discuss today. So the moment you push the ground in the backward direction, the ground pushes you in the forward direction, and this is how you are able to walk. Ground, you are pushing the backward direction as an action, and the ground pushing you forward as a reaction, and hence we are able to walk. Okay. Another example is the time you swim in the water. So while swimming, next is your swimming. So while swimming, what we do? We just push the water backward with our hands or in whatever direction we want to swim. If I want to go in forward direction, I'll push the water in the backward direction. And if I want to go backward, then I'll push the water in the forward direction. So this backward and forward push to the water, as a reaction, we are able to change our direction. So if you push the water in the forward direction, the water pushes you backward and you can swim in the backward direction. And if you push the water in the backward direction, water as a reaction force pushes you forward and you move in the forward direction. This is another application. The next is your flying of rockets. We are able to make these rockets and these jets go into the space from this third law only. As same as your case of balloon. In balloon, this air is just coming out of the balloon at certain speed and balloon is rising up. In case of your jet planes or your fire jets, what we are doing is we are burning a lots of fuel in it. So this lots of fuel produces lots of gases. These gases are being pushed downward with very high pressure or with very high force. As a reaction force, the rocket goes upward. Again, the application of Newton's third law. Okay, there's one more there. The man on the board we have done. The case of a hose pipe. So by the time you hold a pipe in your hand and you make the water to come out of it, So you might have experienced that you have to exert certain force to hold that pipe. Otherwise the pipe will gonna move here and there. Why so? Because the water is coming out of the pipe with a very high pressure of forward force, and there has to be a backward force from Newton's third law. So this Newton's third law makes the backward push, and that backward push you have to stop by holding the pipe tightly. So these all are the applications for your Newton's third law. So I believe this Newton's third law concept is clear now. Now we are talking the last topic, that is law of conservation of linear momentum. Now what does that state? So let's discuss now. Law of conservation of linear momentum. I think you people might remember we have discussed in the Newton's second law. What was momentum? Right. So momentum was P representation and V was the formula. Now today we are going to discuss law of conservation of momentum. What does that state? It states that if there are two or more bodies which are interacting with each other, let's say this is M1, this is M2, this body moving velocity U1, U2. And to make them interact, obviously I have to ensure that U1 is greater than U2. So there is a collision, and after collision, this M1 starts moving with V1 and this M2 starts moving with V2. Right, so what we have done here is we have taken two masses M1 and M2, initially moving velocity U1 and U2. There is a collision between them. After collision, M1 starts moving with V1 velocity, M2 starts moving with V2 velocity. So these are V1 and V2 as the velocities after collision. U1 and U2 are the velocities before collision. Now according to law of conservation of momentum, what it states? It states that total initial momentum, or you can say total momentum before collision, is equivalent to total momentum after collision. Means whatever momentum we are having initially, the same amount of momentum we will be having after the collision or after interaction, we can say. But there is one condition. That condition is there has to be no external force acting there. Because if there is external force, then obviously this equation is not gonna stand. Right? So for law of conservation of momentum, it states that whenever two or more bodies are interacting with each other, there is always conservation of momentum. Means whatever momentum they are having initially, the same amount of momentum they will be having after the collision. Right? Now let's discuss this formula with the example. Let's take the example for recoiling of gun, just for instance. Let's say we have a gun or a rifle with mass capital M. So mass of gun is your capital M. Mass of bullet mass is small m. Right? We have fired a bullet and the bullet comes out of the barrel with the velocity of, let's say, 100 meters per second. Right? Or we can simply say V. Or so let's take values here so that it becomes easier for you to understand. This is 2 kilogram. Mass of the bullet, let's say 200 grams. Right? So we have the mass of gun 2 kilogram, mass of bullet as 200 grams, and velocity is 100 meters per second of the bullet after it's been fired. I want to know what is the recoiling velocity of the gun. So as you know from conservation of momentum, initial, that is the mass of gun, initial velocity of gun, mass of bullet, initial velocity of bullet equal to mass of gun, final velocity, mass of bullet, its velocity. Right? Now since before firing the gun, both are stationary. So this U1 and U2 has to be 0. So initial we have the total momentum as 0. After firing, mass of the gun was 2 kilogram, velocity is unknown to us, mass of bullet is 200 grams. Now whenever we have a value other than SI unit, we have to convert it. So this 200 must be converted to kilograms by dividing by 1000. Then multiplying with the velocity that is known to us already, that is 100. So just cutting the zeros, we get 2 into V1 plus 20. Now just rearranging the terms, we get V1 is equal to minus 20 upon 2, which gives us minus 10. Now this minus 10 meter per second is having a negative sign, which indicates that direction of the recoiling of gun is opposite to that in which we have fired the bullet. So this was all about this fourth chapter. Now we have completed the chapter. Very soon I will be sharing an assignment which will be including all the important questions which you must know to have a better understanding of this chapter. So see you in next class.